Forces in Motion by C.G. Deliawe, Damilolo Shibamoa, and Jessica Ayambule at Cedar Hill Collegiate High School.
Forces, 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 a push or a pull, a push or a pull. Forces, 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 a push or a pull, a push or a pull. Forces, 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 a push or a pull, a push or a pull.
Hey, so what exactly is a force?
Well, a force is a push or a pull applied on an object.
Really? I thought there was more to it than that.
Well, you see,
A force is a push or pull upon an object that results from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Forces only exist as a result of an interaction, whether it is seen or not.
Now we're going to talk about the different types of forces. Well, here we have our Batmobile. Pretty cool, right? Well, with this type of object, it's going to have a force of gravity. You're probably wondering what that is, right? A force of gravity is a force that acts downward on the object. It makes the object stay on the surface of the earth. Without gravity, the thing could just go all the way up and never come down. And we won't want that, right? The next force that can be applied on this object is an applied force. See? When I push it like this, there's an applied force on the object. This causes the object to move in a direction. Because there's an applied force, it has to have friction force too. With the friction force, it slows it down because it goes the opposite way and the object doesn't just go forever and ever and ever because of the friction force. The next force on the object is the normal force. This is the force acting upward on the object. It contradicts the force of gravity. It's what's holding this car up right now. It's called the normal force.
Types of forces. Applied force. An applied force is a force that is applied to an object by an external entity. Gravity force. The force of gravity is the force in which the Earth, Moon, and other objects attract objects toward themselves. All objects on Earth have a force of gravity directed downwards, also known as weight. Normal force. The support force acting on an object that is in contact with another stable object.
Is a force that is applied whenever an object is being held by a string or a rope. This force always goes up.
Tension force. The tension force is the force that is transmitted through a rope, string, or anything being pulled. Friction force. Friction is the force applied by a surface as an object moves across it. Coefficient of friction. It is the ratio of the force of friction to the normal force acting between two objects. This symbol represents the coefficient of sliding friction between the two surfaces. It is always less than 1 and has no unit. These are the equations that you use for the coefficient of friction. Static friction versus kinetic friction. Static friction occurs when two objects are in contact but not moving. Kinetic friction occurs when there is movement between two objects which are in contact with each other. Spring force. It is basically the force applied by a compressed stretched spring on any object to rest or equal position. Free body diagrams. Free body diagrams are used to show the relative magnitude and direction of all forces acting upon an object in a situation. The size of the arrow in a free body diagram represents the magnitude of the force. The direction of the arrow shows the direction that the force is acting. Each force arrow in the diagram is labeled to indicate the type of force. As you can see here, we have an example of a free body diagram. For example, a book is at rest on a tabletop. A free body diagram for this situation looks like this. We have normal force going up and force of gravity going down. Newton's laws of motion. With this demonstration, we can see all of Newton's laws of motion in action. Newton's first law, an object at rest will remain at rest unless acted on by an unbalanced force, often called the law of inertia. This is seen by Jessica presenting the unbalanced force. Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed. The mass of the car wasn't very great, so not much force is needed. Third law, for every action there is an equal and opposite reaction. That is to say, wherever an object pushes another object, it gets pushed back in the opposite direction equally as hard. As you can see, the car ricocheted back off the wall equally as hard. Net force. Any object that has forces acting on it has a net force. The net force is a vector sum of all the forces that act upon an object. In other words, it is the sum of all the forces acting on an object. If an unbalanced force exists, then you add the forces to get the net force. Forces pointing left and down are negative. Forces pointing right and up are positive. If the forces are balanced, then the net force is 0. For example, as you can see here, we have 5 plus 5 going right, so that equals to 10 going right. The next one has 5 going right plus negative 5 going left, which cancels out and equals to 0. In this next example, we have 1200 newtons up and 800 newtons down. So the net force would equal 400 newtons up. Net force can also be found by using the equation force equals mass times acceleration, where F is force, m is mass, and a is acceleration. Torque. A torque is an action that causes an object to rotate. Torque is not the same thing as force. It is created when the line of action of a force does not pass through the center of rotation. The line of action is an imaginary line that follows the direction of a force and passes through its point of application. The lever arm is the perpendicular distance between the line of action and the center of rotation. This is the equation for torque. Torque is measured in Newton meters because the lever arm length is measured in meters and the force is measured in newtons. When these are multiplied together, you get torque. Newton's law of universal gravitation. Any two objects attract each other with a gravitational force proportional to the product of their masses and inversely proportional to the square of the distance between them. Here we see the equation for universal gravitation, where g is the universal gravitational constant. In conclusion, today we've learned about what a force is, which is basically a push or pull. We have learned about all the different kinds of forces and the coefficient of friction. We have also learned the difference between static and kinetic friction. We've learned Newton's laws of motion and how to draw free body diagrams, net force, torque, and universal gravitation. Thanks for tuning in.